Hi everyone, in lesson 1.2 we are going to explore negative bases, and by the end of this lesson you should be able to understand the difference between a negative power and a negative base. They sound very similar but they're different, and we want to be able to change a base from a negative to a positive base by exploring the negative sign in front of it. So before we get into the questions, let's just explore negative bases. And the way we're going to do this is by writing as these two powers as repeated multiplication. Now remember, we said, like, for example, if I had 7 to the exponent 14, we know that the base is 7, the exponent is 14, and the power is the entire quantity 7 to the 14. Now, if I could evaluate this by putting it in my calculator, I would, but this number is so big that we can't actually evaluate it. So we're just going to leave it as a power as it's written. So in order for us to understand the difference between negative bases and negative powers, we first have to explore what negative bases are a little bit more closely. So what we're going to do is look at number 1a, and we're going to write two different powers using repeated multiplication. So if you recall, last time, or just right now, we reviewed that negative 3 to the power of 4 represents repeated multiplication of a base. In this case, our base is negative 3 because the exponent, the brackets indicate that is our base, all raised to the exponent of 4. So what we do is we multiply negative 3 by itself 4 times. And what we'll notice is when we evaluate this, the result is positive 81. And something to notice is the reason that this overall power is, the overall number is positive, is because we have an even number of negative signs that cancel out. So the negative signs cancel. This is in contrast to our next power. Our next power is negative 3 to the exponent 4. But because there are no brackets around the negative value, the exponent of 4 only applies to the 3 and not to the negative in front of the 3. So actually, if you want to think about it this way, there are brackets here, but we don't usually draw those in. So the way we're going to write this repeated multiplication is we'll put a negative on the outside of the quantity, and then we repeatedly multiply 3 4 times. So we end up getting negative 81. So what we'll notice is that negative 3 to the power of 4 has a negative base, but the overall power is positive. The overall result. Here we'll notice that our base is actually positive because it's 3, and our overall result is negative. So what we can notice is that it doesn't really matter whether the base is negative or positive per se. We have to also look at the exponent to see whether or not our overall power will be negative or positive. Let's do one more example. So I have negative 3 to the power of 3, and we can see that the exponent of 3 applies to the negative as well as the 3 because the base of negative 3 has brackets around it. When I multiply this, I can see that the negatives of the first two bases cancels out, but then I have a third negative. So my overall quantity is going to be negative 27. And in my next case, remember, the exponent of 3 does not apply to the negative, it only applies to the base of 3. Maybe I should write this down. Base is 3. Base is 3. Base is negative 3. Base is negative 3. So just to make it clear what the bases are in this question. So in this case, we're going to write negative 3 times 3 times 3 equals negative 27. So you'll notice that in this case, negative 3 to the power of 3, to the exponent 3, the overall quantity is negative, and negative 3, sounds the same, I know, but in this case the base is 3, is also negative 27. So here we have a negative base and a negative power, and here we have a positive base again with a negative power. So without evaluating, so these numbers are small and we can write them out in repeated multiplication, but let's extend this idea to numbers or to exponents that are really large. So for example, if I have negative 9 with brackets around it, all raised to the exponent 99, I can see here that my base is negative 9, and what I'll notice is my exponent is 99, which is an odd number. So what that means is it's going to look a lot like this case right here, where I have a negative base with an odd power, meaning that the negatives will cancel out up into exponent 98. And then when you add that last multiplication, we're going to have a leftover negative value. So we're going to write this as negative bracket 9 to the 99. And what that means is my overall result will have the size of 9 to the power of 99, which is a really big number we can't evaluate, but I know that the overall quantity is going to be negative. So I know that my power here, my overall result, is going to be negative. Now in the next case, B, the answer is really easy because the base is positive. In fact, there's no negative here at all. So I know that my overall answer is going to be 7 to the exponent of 82, and it's going to be overall positive, okay, because there are no negatives there at all. Now in C, I can see my base is negative 2, and I also have an exponent is even. So that means if I were to do repeated multiplication here, my negatives would actually cancel out and my quantity would be 2 to the power of 120. Overall, I would have a positive quantity. Now in my final example, my base here is 5. It's a positive number and the exponent is even, right? Let's write it all out. The exponent of 22 is even, but because there's a negative in front of the whole power, I know my overall result is going to be negative. So what we can do when we encounter negatives in our bases or in our powers, we should be able to think about it as an overall negative or positive quantity based on the exponent. So in this box, we'll just recap what we did. A positive base will always produce a positive result, okay? But if the base is negative, we need to look at the exponents. So if the exponent is if the exponent is even, the power, the overall power, will be positive. If the exponent is odd, we won't get that pairing off of negative values canceling out. We're going to have one leftover negative value, and so the overall power will be negative. So let's put this concept into use. So we're going to do a few questions now. So we don't need our calculator. In fact, we don't want you to use your calculator for these problems. We want you to use the laws. And we don't want you to evaluate. We just want a single power. So let's look at part A. So part A, I can see that I have two powers being multiplied. And here, for the first one, I can see that my base is -3, and it's raised to the power to the exponent of 71. For the second one, I can also see my base is -3. So the exponent of 2 would apply to the negative and the 3, and the exponent 71 would also apply to the negative and the 3. So I know that, let's do the easier one first. I know that -3 to the power of 2, well, -3 to the power of 2, because that is even, I can write it as 3 to the power of 2, because I know my power in the end will be a positive quantity. Conversely, I know that -3 to the power of 71, well, that's going to be overall negative. So I'm going to write the power as -3 to the 71 with the negative on the outside. Now what I'm going to do is use my exponent law that I learned in lesson 1 to simplify this. So I get negative, which remains on the outside, 3 to the 71 plus 2. All right, let's look at the next one. So in the next one, I can see that my negative value is on the outside, and my base here is 7. So what I can do is leave the negative on the outside, and I'm going to use another exponent law to help me here. So I need 4 to the power of 55, which I believe is 220. That's right. I know my overall quantity is going to be negative. All right, now let's get into some maybe trickier ones. Okay, so here I can see that my base is -2. The 17, the exponent of 17 is going to apply to the negative and the 2. Since that's odd, I'm going to write that as -2 to the power of 17. Now I'm going to divide by, again, a base of -2. And I know it's -2 because the 9 is on the outside of the bracket, and it's going to apply to both the negative, to the negative and the 2. I'm going to write this division like this. So I know that I have a negative quantity over another negative quantity, and those two negatives are going to cancel out. Okay, and now I can use another power rule to say that my overall quantity is 2 to the power of 8. All right, 2 more, and these ones are a bit more complicated. All right, so let's look at D. So in D, I can see that my base here is -2. The 5 applies to the negative and the 2. The middle one, the base is also -2. The 6 applies to the negative and the 2. Now we're really trying to trick you here in the last one. In the last one, the 18 is only touching the 2, but not the negative. Okay, so -2 with the 18 on the outside is different than -2 with the 18 on the inside. So on the outside, the exponent of 18 would be applied to the negative and the 2, but in this case, the base is just 2, and the 18 is applied to just the 2, but not the negative. Here the base is -2. So that's just like on the side, an example, or a clarification. So here, guys, what we're going to do is use our exponent laws. Remember, we can combine a to the m to the power of n is a to the m times n. And in this case, we know that -2 to the power of 6, because it's even, is the same as 2 to the power of 6. And in the last step here, I need to leave this quantity as a negative quantity, because although this is, the exponent is even, it's only being applied to the base of 2. The negative is on the outside. All right, so here we go. -2 is our base. The exponent is odd, so I have to write that as -2 to the power of 15 times 2 to the 6 divided by negative 2 to the 18. Now, if we want, we can rewrite it like this. And again, I can see I have a negative quantity over a negative quantity, and I can get rid of those negative values because I know my overall answer is going to be positive. So my final answer will be 15 plus 6 minus 18, and that's going to be 2 to the power of 3. All right, last one. Okay, so base is negative 5. Base here, 5. Base here, 5. Okay, because the 15 doesn't apply to the negative and the 18 doesn't apply to the negative. So in this case, I'm going to get 5 to the power of 4 to the power of 9 because I have an even exponent. And at the bottom, I can see that my negative 5 to the 15 is an overall negative quantity. My negative 5 to the 18 is an overall negative quantity. So together, these would be, multiplying them together, I'd get a positive quantity. 5 to the power of 15 times 5 to the power of 18. So we can see now that overall my answer is going to be positive. 5 to the 36 and 5 to the power of 33. Overall my answer is 5 to the power of 3. So I know these are a little bit challenging. I'd like you to make sure that you do a bunch of practice with this. If you don't get it, please ask your teacher. Please come to extra help. What I'd recommend now, guys, pause the video, try the next questions, and then come back here and make sure that you got them right. Okay, so I would pause now and give these a shot.